Good evening, everybody. Welcome to week 4 of Advanced Programming with Java here at Portland State University. We're at the midway point of the course, and starting tonight, there's an inflection in the course. Stuff that we do in the latter half is different than the first couple of weeks, and hopefully it's stuff that you find more interesting and more compelling, but it'll also be more challenging. What we're going to focus on tonight is Project 4 and understanding what that's all about, because there's some new stuff. Sorry, I'm in the light. So it's going to be a little different from last week where we did a lot of coding and stuff. I don't know if we're going to get to the katas. We'll see how things go, and we'll see how everybody feels. But first, let's start off with some Prime Minister's questions. So what can I tell you about what you've been learning so far in the course, your projects 1, 2, or 3? What questions remain open? Yes?
So I guess the overall flow for 3 then is essentially do all the same stuff, implement some date things, and then the file IO stuff where we didn't really care about what format it was in before, and now we want some kind of nice printouts to the text file that's going to look like a nice human readable kind of thing. So
so Project 3 is really an increment on top of Project 2, right? You'll be using some new APIs, and the new APIs are the datetime formatting and parsing, right? That's what you're meant to learn there. And yeah, as far as the flow of your program, it just does a little bit more stuff. Once again, you are formatting text, but in Project 2, where you formatted text that a computer could read, so your text dumper it has a corresponding text parser to be able to read it back in. In Project 3, you are formatting text that a human should be able to read, or at least our graders. They're people too. Yeah. So I mean, I think that fundamentally that's it. There's here again, it's an increment, and so hopefully it's nothing too new or earth-shaking. And that's good because you've also got your cones to finish off this week. So, yes?
It looks like there's 2 printing command line options. So one of them keep the same dumper and parser that we had before, and then on top of that we have something that writes to a pretty file.
So yes, I mean there are more command line options, and we keep adding more of them. So in Project 1, well, we always have the dash readme. Hopefully you know what that is by now. And dash print. Dash print is just printing the phone call that's there on the command line. That does exactly the same thing. Project 2, we added the dash text file, which is where the phone bill is read to and written from. And then in Project 3, we add the dash pretty, which then pretty prints it. Makes it in that human readable format. You can write it either to a file, or if the argument to the dash pretty option is dash itself, it prints out to standard out. Yes?
I was wondering how we submit the codes, because the submit program has you list all the files you want to submit.
I think you can use a submit program. Let me
It says to put the whole source folder
into a zip, or I'm trying. Yeah, I'm trying to. Thank you for reminding me. It's been a while. I think I describe it. Oh, there you go. Yeah. So you say cone source, and I think it's smart enough to say, oh, you're submitting the cone, so it's not going to look for like edu, pdx, cs410j nonsense and stuff. Yep. So that's where it is. As a matter of fact, a handful of people have already submitted it, so I know that it works. So like, if you're having problems with it or you're not sure, reach out to me and I'll let you know. Good call there. How's everybody doing on the cones? Hope you haven't forgotten about them. Yeah, making sense. How are you finding them? Are they helpful? Are they tedious? Are you achieving a Zen state of unconsciousness because you're so bored by them? No? Yeah?
I would argue that a lot of them are trivial. Like, it's not my intent to look at what they expect, but the fact that it tells you exactly what they expect right there, it's like, I have to like cover up the part of the screen where I'm like, okay, just look at this line and see if I can solve stuff. And
yeah.
It's almost like you need to do all of them without this running first. Because having it running right next to it,
right.
It's just saying, I expect 3. Okay, well, replace with 3. Done. Like,
yeah. Yeah, and so, yeah, I mean, the feedback is, it's like, for a lot of them, it's like, you know, the output tells you what the answer is, and it's really hard to just type that in, and 80% of the time it works. Sometimes it's a little tricky because it's like, oh, that really wasn't what you thought it was. You know what? Actually, it just occurred to me. It might be good. It would be nice if like it didn't tell you the answer until maybe the second time you attempted it, right? So it sort of progressively gives it, and maybe I can provide that feedback to the author of the cones, or I can write it myself, or one of you can write it. You guys can fork it. Get up. Yeah, there you go. Bonus points. Yeah, I guess I might do an independent study. Anyway, I got people for that now. Okay. Good. Other people's experience with the cones. What'd you think?
Sometimes it syncs up with the projects.
Oh, good. So stuff that was relevant to the projects in there? Excellent. Good, yeah.
I was sick when the term started, so I just did them all before I did project 1.
Oh.
And it was tedious at times, but also I think helped when I started to actually do stuff on that.
Did it help with your illness? Was there like some sort of magic? Like, yeah, no. It's like naturopathy, but it's coding pathy. I don't know. No.
But
Got you feeling better.
The point's not to teach you how to program. The point's to teach you how Java does this.
Exactly. It's all about the language, right? So this is not where you're going to necessarily learn how to structure your code or how to decompose it because they're so small and so short, right? It's all about understanding the language syntax, some of the APIs, and how to use them in the small, but hopefully it gives you, when you look at them overall, it gives you a better appreciation for the language as a whole, and then you're able to use some of those in your projects. Okay, good. Okay, cool. Yeah.
So are we going to see any kind of examples of more interesting / complicated unit tests? Because for the most part, we've seen unit tests that do real simple things, but like testing for files is a lot harder. Testing for scanner I/O is a lot harder.
Yeah.
Testing for all these more complicated things.
Yes, tonight we will see that. So tonight, and I'm not quite ready to go there, so I'll say yes, tonight. Stay tuned. Yeah, cool. So got lots of good questions about Project 2. Hope you have those submitted or is about ready to submit. Project 3, there were a couple of questions already asked tonight, but any other things about Project 3? So here we assign that. Yeah.
I noticed that, so if you feed the date constructor along it that corresponds to, say you translate February 30th, it just turns it into March 2nd. Is that okay?
I'm not going to test those validations because you're right. I mean, the way that the well, you said you use the date constructor,
Yeah.
so not a date format. Yeah, the date constructor. I think that one's deprecated though, right?
Well,
One of them.
The date stuff was deprecated.
So maybe you shouldn't use those. But yeah, because of that,
I mean,
because
the
that kind of
whole
weirdness,
date
right?
Class was deprecated.
That's a good point. These days, yeah, they added a bunch of new stuff in Java 8, the whole like Datetime and the what used to be known as Datetime.
But that just is taking Unix time. I mean, it seemed cleaner to construct a date out of.
It doesn't give you necessarily all of the, well, there's a reason they're deprecated, and some of it is that behavior you just mentioned, where it's like, oh yeah, February 30th, it's just the way it was implemented 20 years ago, and they realized that it's not the best thing for right now. That being said, I think, I'm pretty sure for Project 3, I don't do any semantic validation of the dates. It's just
Beyond
syntactic,
that,
yeah.
You said just to make sure the first date doesn't come after the second.
Exactly right. The only requirement is that the start date precede the end date. So then, you don't need to worry about me testing February 30th or 27 o'clock or anything like that.
Or they can be equal, like a hang up.
No, I'm not going to test that either. Yeah. So, and actually, I was talking to one student, and they were saying that it's like, they implemented all this other validation, like, a call should last, no longer than a day. I'm like, yeah, maybe in the real world, but this isn't the real world. And so I'm trying to think, it's like, do I have anything like that? It's like, well, I might. So, on the one hand, yes, validation is a very important part of the assignment, but then also be judicious. I think something like that, though. I mean, if you fail a test because of that, I'm going to ask the graders to be lenient. I'll probably let you, fix it and regrade it, that kind of thing. So, but I guess don't go too overboard in trying to make to try to constrain what the user can put in. Yeah.
So on that note, you have a requirement that we have the duration of the call.
Yes.
Is there an expected format, because that call could be minutes,
It's
hours,
it's
days,
in
seconds,
minutes.
like-
Yeah, I said in minutes. So that's sort of like the bare minimum. I don't think I have too many multi-hour calls. So if it just says whatever 57 minutes, that's fine. Okay, project 1, 2, 3. The cones. We got the quizzes. I didn't send anything out, but quiz 1 and 2 were graded already. So if you have any questions and you don't already have the contact information of the grader, then let me know, and I can put you in touch. Okay, that was last week. Let's close this out. Okay, let's get started. So the first 3 weeks of the course are like, the kinds of things that you do are the kinds of things that we've been doing in computer science classes since like the 70s. You're doing command line output. Yay. And this is important to know. It's good to have that background. Those first 3 assignments are really about learning about the language and the build environment, how to write unit tests, and stuff like that. Starting in Project 4, things get more interesting. And what we do is we leverage the information in this reflection lecture and also the foundations of the web to write a client-server application. And so this is what we'll focus on tonight. Okay, so in Project 4, you instead of just having a command line program that manages your phone bill, you have a client. You have a phone bill service that is 2 parts. The first is a web application that stores the phone bill information, and the second part is a command line application again that communicates with that web application over HTTP using something called REST, which stands for Representational State Transfer, which is basically a way of having a CRUD API over HTTP. There's much more details in the lecture. I don't think I need to go into too many of them right now. This is cool because it's different. And so here, what we're learning about isn't so much our phone bill application. As a matter of fact, I don't think there's really any new functionality in phone bill. Instead, what you're going to be experiencing is exposing that functionality and interacting with it in a different way, because the requests will be coming over over HTTP, over the web. And you'll be working with it both on the server side, basically learning how to expose, again, your phone bill through the web, and also on the client side, learning how to make HTTP requests from Java code. So this is very different, and as such, we'll see for the rest of the class sort of how you work with it, what the pieces parts are. It's a new it's a new kind of Maven application. So you'll create a new Maven project from a new archetype. And I think most importantly, and I think this is where the real learning comes in, is that you now have a distributed application. You've got 2 processes. And I don't know how many of you have experienced really working with distributed programming, but it's a whole different dimension in terms of how you need to think about your application, how you design your application, how you debug your application. And so what I'm going to try to convey to you tonight is how to build a web application in Java. You'll see a lot of new things, especially if you haven't gone through the web lecture again. A lot of things that might be kind of new and very different. It might go over your head. This is why I record it, so you can go back and review it again. But let's first talk through the assignment. Then we'll go and look at some code, and we can come back and forth. Oh, that's awesome! Gotta admit, I kind of like being in the fine arts building, right? It's a soundscape, but it's mostly the streetcar. Okay. You'll still have all of your classes from projects 1, 2, and 3. You'll have your phone bill, you'll have your phone call, you'll have your text parser and your text dumper. Although I guess you really don't use the text parser and text dumper anymore, but you definitely use your pretty printer. there are now two pieces to your project. There is one which is the web server. And in Java, there is an API called the Servlet API, which is an object. A servlet is an object that is invoked when the web server that it runs in, the web container that it runs in, it receives requests for certain URLs. So, right, you guys know what the web is, right? Okay, think about a web browser and type in a URL and you hit return. I hope you've thought about what happens there. Maybe or maybe not. You've learned about it and experienced it. But the whole idea is that you hit a URL from someplace and that gets routed to some machine out there on the internet, and the communication is done through what's called the HTTP, the Hypertext Transport Protocol. And as we talk about in the lecture, when you've got a Java server running a web container, the web container is responsible for taking that URL, picking it apart, routing the request off to a servlet object that then handles it. We'll see lots of details of this in a few minutes, but you're going to create, or actually, well, you're going to author a class called PhoneBill Servlet, which provides a REST API on top of your PhoneBill. This REST API is expressed in URLs, and then the HTTP verbs that are supported by those URLs. How much HTTP and HTML experience do you guys have? 0, a little bit, not much. Okay, so then we'll talk tonight. Please go back and review the lecture on REST. This is important stuff. And it's important stuff because we all use the web, but as software engineers, we need to know how the web works, and in particular, how to build applications. This stuff is all standard. This stuff is also very, very important. And I think ultimately people think it's magic, and it's not. It's computing. It's software. And so I think it's really beneficial not only for this course and this project, but just in general. To be a good software engineer, you have to understand how all this stuff works. That being said, I'm probably a little biased because this was all new and sexy when I was in your seat 20 years ago. I graduated from college 20 years ago, which is crazy because it was a long time ago and it makes me really old. But anyway, and this stuff was well, it wasn't new and shiny, but this is, we all thought we were going to be millionaires because we learned HTML. And some people were, but then some of us weren't. So anyway, back to this. You're going to implement this thing called a servlet that we'll see in a little while. It handles URLs. And when you send this URL to your web container, to your web server, with the get verb, so it's like, hey, get this URL, it should return all of the phone calls in the phone bill associated with this customer using the pretty printer. So, boy, I hope you know that HTTP is well, I guess it can be any type of data, but it supports text-based data very well, like your pretty printer. When you hit that URL with a post, it will create a new call in that phone bill, and you provide the information for the phone call in HTTP request parameters with the names customer, caller number, callee number, start time, and end time. And note that if a phone bill for that customer doesn't exist, you should create a new one. So this is a different API for dealing with, well, it's an API on top of the Java code that you've written. It's a REST API, an HTTP-based API for your phone bill. So that's one URL that does a bunch of stuff. And there's another URL. Well, it's the same base URL, but when you provide additional parameters to it, when you send a GET that has both the customer name, start time, and an end time, this is some new functionality to your project. So I guess I was wrong. There is some new stuff that you need to implement on the back end. And this queries the phone bill and looks for phone calls that occur between a given start time and a given end time. And it returns those in the pretty format, which I guess I don't specify here, but that's what I meant. So that's what you'll be doing on the server side. And so then this exposes, again, this HTTP interface, these REST APIs, for interacting with your phone bill. You'll still have a command line in this project, but whereas your command line program in projects 1, 2, and 3 work directly with the PhoneBill. Now what it's going to do instead in your project 4 main is it interacts with your PhoneBill remotely using HTTP requests. So it still does a lot of the same things, and all the same things, because there's no file involved anymore. But but now it does it remotely with the web server. So let's see here. Well, the command line should look pretty familiar to you. Once again, it has the same arguments. So the customer caller number, callee number, start time, and end time. And we're still in with AM, PM, so just like in Project 3. So that hasn't changed. But now we've got some different options in this command line. When you invoke this command line, you need to tell it where to make where to make the request. So you need to give it the host name for the web server and the port that it runs on. Let me back up a second. You know what I mean when I say host name and port? You know what a host name is, right? Host name is, right? Machines on the internet. Yeah, machines have names, right? So like when you SSH into your ruby.cs.pdx.edu or whatever the domain name is, that goes to a machine, right? And there's like DNS that basically translates that name into a location on the internet that can go find. Someday I should really teach like a networking course. Maybe I should just turn this into a networking course. Anyway, networking is really neat. And you know, okay, I'm going to diverge here. Again, it's like we all use the internet, but so many people, especially outside computer science, but even within computer science, don't really understand how all of it works, which is weird, right? It's kind of like I use this computer, but if you didn't learn about what the CPU is or what memory is, maybe you can get a lot done, but you don't really understand the system that you're working in. And I think that's really important, especially for people that are going to pursue a profession, career in this field. Sorry, back to the assignment. So you need to tell the command line where the REST API lives, what machine, what port it is. And so if you provide just the arguments and host and port, then you create a new phone call in the PhoneBill. But you can also exercise the search functionality. And in search, you don't need the caller number and the callee number. You just need the start and the end time. I've got some examples down below. And you still have dash print, and you still have dash readme. So you have, again, you've got a whole bunch of functionality on the server, and then you've got a command line program for exercising that. Yes, question?
So you state that the search option provided customer name is also important. Is that
yes.
That we can have multiple customer names?
Yes. Okay. So, and I think I get to that. I guess, so you have to have both. If you're going to have a host, you also have a port and vice versa. Here's an example of, oh, wow. I think that was my phone number when I lived in Indiana. Anyway, here's how you add a phone call to the server. So you've got your server running. We'll see how to do that in a little bit. So you run your command line program. With the host, with the port, and then you got your customer name, caller number, callee number, start and end time, and that goes off and adds it. And so you run that multiple times, and then you can search for calls. Begun. So this is the begin time is between certain times, and so like this is, for instance, if you want to search for all the calls started in the month of March, it goes from March 1st to March 31st. And again, you just have, oh, do I not have dash search on there? I don't. I suck. Okay. You need to have dash search like right here or in any order. Actually, sorry, you need to have it right here. Oops. Someone email me about that or put an embarrassing picture up on the Google community or something so I fix that. Right. So those are the two command line invocations. And again, this all interacts with your server. The nice thing about this is, okay, how did we persist the data in projects 2 and 3? So I create a, so remember everybody said Project 1? Project 1's so stupid. I add a phone call and then it goes away. Well, why was that?
Save it.
Right, we didn't save it anywhere. Okay. In Projects 2 and 3, it stayed around. How do we make it stay around?
In a file.
Right, we grow it to a file. In Project 4, we make it stay around because it lives there in the web server. So as long as the web server's up, the phone bill is going to be there. The phone bills will actually be there. The way we implement Project 4, if the server goes away, so do all the phone calls, so not the real world, but I figure that's good enough for Project 4. And we'll see how all this works in a little bit. So now, instead of, you run your program multiple times and everything gets stored off in the server instead of a file. Okay, so the usual caveats about exiting gracefully. We've got some new error conditions now. So in addition to the command line being messed up or the date isn't formatted correctly, now if you can't connect to the server or if you get an error message back from the server, you should issue a graceful error. So that's this is like the user-facing functionality. All right, the user sees this command line. But in order to do this, we need to implement some new stuff. So there'll be a new Maven Archetype. And you know what? I think, yeah, I'm just going to now switch over and start doing it and start talking through it. Unless there are any questions that people think sort of like relate to what the functionality ought to be. Anything? I think we're okay, because I think the interesting stuff comes next. So it's a different kind of project than your Project 1. We created a Maven project for Project 1, and it was easy, right? You had a couple classes, you had a main method, you had Maven configuration that did things like create an executable jar, you had your integration tests, your unit tests that could test the Java code, and you had the integration tests that test the command line. And this was great, right? Because it gave you kind of everything that you needed all in one Maven project. That's one of the nice things about Maven is that it handles your entire application lifecycle. For Project 4, you're going to be building a Java web application, which uses a bunch more stuff. You still got Java source code, but now you've got source code for the stuff that resides in the server, like your servlet, as well as your PhoneBill class and your phone call class. And then you've also got source code for your client. Okay, well, it's all Java at the end of the day, so we'll keep those guys separate. You also have some new APIs. You're going to be using the Servlet API, and that's a standard API that you need, that Maven will let you depend on and fetch easily. But you still want to be able to unit test and, more importantly, integration test your software. So unit tests are unit tests. It's still JUnit. Although you do have these APIs, like the Servlet API that you deal with, and so we'll see how to do unit testing in unit testing of servlets in the with the Maven project. But more importantly, you want to have integration tests. So a couple weeks ago, someone asked, "Hey, what's the difference between unit tests and integration tests?" Look at what you have in Project 1. It's all Java code. You're just maybe you're invoking your main methods in a fancy way, but it's all the same thing. Well, now you'll see the real difference between integration tests. In Project 4, when you run your integration tests, what it does is it compiles all of your code and then starts up a web server, deploys your code to that web server, and then runs tests that don't execute the code directly. Instead, what they do is they hit the URLs, just like your command line program would, and interacts with it that way. So this is really powerful, right? So not only do you get the unit test and it tests the pieces individually, but now you also get the true integration test that's running, pretty much the same environment that you would in production because it's starting up the web server and your program's really running, and you can go and interact with it that way, just like the command line program would. But so you're making the same call. So as far as the code under test is concerned, it doesn't know that's being invoked via REST calls that come from an integration test, via REST calls that come from a command line program. It doesn't care. And we'll see examples of this. So anyway, lots more complexity, but also lots more power, right? You're doing much more interesting things. Okay. Yeah, okay, cool. So there's a new archetype that we run. But first, we need to do something with our old PhoneBill. So let me. We want this thing to be called PhoneBill because the artifact name is in the URL. So we want to rename the old PhoneBill. So we'll say git move. Actually, wait. Get pull. Anything new here? Oh, some new stuff. Okay, GitHub pages. No big deal. And get status. Do I have any changes? Oh, I'm on that branch. Haha. Yeah. Get checkout master dash b master. Oops. Checkout dash b master. Okay. Fine. Don't dash b it. Get status. Everything's clean. Get pull. Already up to date. Good. Okay. So I'm going to create a new project called PhoneBill, so I'll get this one out of the way. So I'll just use git move because I think it'll be easier. PhoneBill, and we'll just call it PhoneBill command line. Nice. So I'll do that. Rename the PhoneBill, or the old PhoneBill directory. Okay. Oh, probably should make sure that still works. Well, it'll tell me if I don't. Okay, the wind. It's haunted, spooky, the ghost of. It's not Abraham Lincoln Hall. It's actually Frank Lincoln, his lesser-known brother. No. Yeah. Okay, so now I'm going to create a new project called this. It's going to blow up me because it's like my login. Okay, so now I guess it's important to note here that the archetype is this PhoneBill web archetype. But everything else should be the same. So your version December 2018, yeah, that's fine. Oh, what doesn't it like? Yeah, I messed something up. Oops. I forgot to rename something in the parent POM here. PhoneBill command line. Actually, since I'm here, let's just do a Maven clean verify before I try to create anything new. Actually, is there? Wait, it didn't create anything new, right? No, okay. So Maven clean verify. What I had done, and if you watched one of those screencasts I made on the 4th of July, I took all of these projects that we made, like on the first and second, on the first class. I made a parent project for all of them, so now I can run them all at once. This was really helpful for that Travis CI continuous integration, because now it's sort of like one command to build all of this code here in my repository for the summer. Great, and everything's happy. As a matter of fact, if I go off to Travis now, Travis CI. Probably failed. Oh, really? Oh, yeah, right. It's the, that would do it. It's the year 218 in octal. No, I don't know. Zero, leading zero? Nerd. Okay. Oh, yeah, it started and it's probably going to fail because that's weird. Anyway, did anybody actually watch the screencast where I talk about this with Travis CI and everything? Yeah, somebody did. Ooh. Good for you. Wow, it's taking a while to do that, so maybe it's very busy right now. Well, here's what I've got. Every time I do a push to my Git repository, I have this thing go and get a new checkout of all the code and rebuild everything from scratch just to make sure that my code can be built in a clean environment. And so that's what it's doing right now very slowly. I don't want to watch it, though. Okay. So now this seemed to have worked. And so actually, reading the old phone directory in the pom.xml. Oh, pom.xml. There we go. Okay, that should be better now. Now I should be able to create my archetype. That looks good. Okay, so now I should have a whole bunch of stuff there. Git add PhoneBill. Yay, all sorts of stuff. Let's do another clean verify. To see if that works. So, as you might recall from the first day of class, you use this archetype, and what that does is it gives you all sorts of files there for your project. I just want to make sure everything runs first, and then we'll spend the rest of class basically walking through what the archetype gives you and how to work with it. So I want to make sure everything works before I invest too much time in figuring it all out. But I think it seemed to. So, oh yeah, there's the PhoneBill server going by. Seems pretty happy. Sweet. Okay, I think it's okay. Yep. Okay, now it's running the integration tests. So actually, what it's doing right now is it started up a web server, ran a bunch of integration tests with it, and then it good. It all completed successfully. So I'll commit this. Added a new project for the PhoneBill REST/web assignment. Okay, where to start? Let's start at the very beginning. I'm going to open my project. I might need to refresh it because I just added a whole bunch of new stuff to it. PhoneBill command line. It's probably thinking about it. Great. Web framework. Oh, they're both called PhoneBill? Well, that's neato. Okay. Question, yes.
I noticed, I think you maybe answered this one for you.
That's okay.
Why do you not use Maven in IntelliJ?
Why don't I use Maven in IntelliJ? A long time ago, I had problems with it, so I stopped doing it. Conceptually, and this might just be personal preference. I sort of like do IntelliJ things in IntelliJ the IntelliJ way. I do Maven things on the command line the Maven way. I think it's meant to be used inside, but really what I do in IntelliJ is I write my code and I run my unit tests, and that's it. Right? I don't want to build my jars. For me, that's more of a command line thing. But I think that might just be me. I think perhaps the JetBrains guys would want you to do your Maven stuff in IntelliJ. But really, I don't have that many Maven things that I do. Again, what I do in IntelliJ is I write my source code, I run my unit tests, I debug my unit tests, I debug my code running. And I guess conceptually for me, and this here again, it might just because of how I learned to code and being a little old school and stuff. There's something about running stuff from the command line and debugging it in the IDE, which is just how I do things. So I don't know if there's really a good reason that I don't. It just makes more sense to me. So yeah, if it works for you, great. I guess also what it means if it's not working for you, I can't help you because I don't do that. But yeah, I mean that's a good question. I think it really boils down to my personal preference. Okay, let's just close all these files. Close all. Okay. Let's have some fun. the Maven archetype for Project 4 creates a simple web application that basically has all of the pieces parts for your Project 4, but they don't do Project 4 things. Instead, there's a very simple application which is meant to give you an idea of how these pieces parts interact, but it doesn't actually do your assignment for you. So, out of the box, what the archetype provides you is a very simple dictionary application. And so what it does is you can run a web server, and then you run a command line program that will add words to a dictionary. You can get words from a dictionary. I'll start off by showing you what it does, and then we'll walk through how it does it. Okay, and actually, because it's a distributed program, it'll probably work better if I have two windows open. Okay. So actually, well, okay. So I'll just do this all from the PhoneBill directory. So this is now my web application, and I'll go to that same directory over there. Portland State Java Summer 2018 PhoneBill. Okay, same directory. Nothing up my sleeve. Over here on the left, I'm going to run my web server. Remember, two processes, two Java programs. One that's the web server, and the other one's the client. So I've already done my Maven clean verify, so I've already built all the artifacts, and so now I'm gonna run a command called Maven Jetty Run. Oops, not un. Run. Okay, so if you watch the web lecture, we talk about something called the web container. A web container in Java is just a Java program that acts like a web server. And the way it acts like a web server is that it knows how to handle HTTP requests and do something with them. Great. So now I am running that web server. Now, over here, I'm going to run my command line program. So, and this should look pretty familiar. PhoneBill.jar. Okay. And then, okay, great. It runs a main program. And it says, okay, I've got 4 arguments, the name of the server, the port of the web server, and then some other stuff. So if no definition is provided, then the word's definition is printed. If no word is specified, all dictionary entries are printed. So the host and the port. What machine does the web server run on? What's the name of it? Localhost, meaning that it's the same, that's the current machine. That's a special reserved name for that. And it runs on port, it usually says right here, well, this tells me it runs on port 8080, which is kind of like the default port there. Okay. Oops. Localhost. Localhost. Okay. And so I run that, and it says that the dictionary on the server contains 0 words. Okay. Sure, I have to print out something on the left, I guess. Now let's add a word. A blue is a bear. Okay, so now I have 1 word in the dictionary, a bear, and if I then go and say, hey, what's the definition of a blue? It says, oh, it's a bear. If I say, give me all of them, there'll be 1 entry in there, a bear. So I'm interacting with the server, and I'm telling it to do things, and it's giving me responses. I'm going to stop the server now, and just to demonstrate, if I rerun it again, if I ask it for everything, it's empty again. So all the data is stored there in memory, so as long as the Jetty process is running, then the data will be there. So, I'm going to add a little debugging. What should I do? No, let's just do the interesting work. So, you've now got 2 programs. How many of you have been using the debugger for your projects 1, 2, and 3? Only a couple of you? Okay, more of you. Yeah, I used it a couple of times. I don't know what your other professors have told you about debuggers, but use the debugger. They're very powerful tools that'll help you understand so much better than print lines. Seriously, it's not cheating in this class. As a matter of fact, I want you to use the debugger. And so what we're going to do here is we're going to run Jetty under the debugger, so that we can then get a sense for what the program is doing and how it does it. So we're going to add a remote configuration here, and we're going to call it Jetty server. And okay, we'll run it on port 505. Oh, this copies it to the clipboard, by the way. And so what we need to do over here is to tell the when Maven runs, it says, "Hey, run Jetty in debug mode," so the debugger can attach to it. Do that by setting Maven ops here. This is in the assignment, so you'll have to go back and watch the screencast to get all of this. That basically says, "Hey, when I run Maven now, I'm going to run it in debug mode so you can attach to it." So it tells you, yep, when it starts up, it's listening on port 5005 for someone to attach to it. And now when I debug this thing, it attached to it. It says, "Okay, great, I'm here." I'm going to set a breakpoint here in the doGet method, and then we'll see how we'll see what happens there. Okay, so my Jetty server is running. I'm going to ask it to give me all of the words in the dictionary. Okay, actually, you know what? I'm going to try something else first. I'm going to turn on this breakpoint, and I'm going to add some data first, and then we'll start debugging it because it'll be more interesting to see, I think. No, we'll do that again. Sorry. I'll edit that out. No, I won't. Okay. So what just happened here? I started my program, and then IntelliJ popped up. And I said, aha, you said to set a breakpoint here, and so now I'm in the middle of executing, and I'm right here on this line. So, while this isn't a tutorial in debugging with IntelliJ, I'll cover some things. So here is the call trace, call stack for where we're at right now. So we just started running this doGet program, which is in our PhoneBill servlet. And all the stuff that calls it is all the stuff that's internal to Jetty. And so the details of it, does it say eat what you can kill? It does. See, okay. Open source, I don't know, you crazy guys. So it's basically saying, oh great, now I'm executing your code. Okay, let's take a step back and look at our servlet and see what we've got. So we have a class called PhoneBill servlet. PhoneBill servlet is in our package, is in my package. It extends something called HTTP servlet. HTTP servlet is a class that is provided by the Java Servlet API. Java Servlets, the Java Servlet API specifies the contract between the web container, which is Jetty, which has all the smarts for taking in that HTTP request and routing it to your servlet. Okay, and there's a contract between the two, and that contract is provided by the Servlet API. And so what I do for what you do for your code is you extend their API, the class from their API, the HTTP servlet, with the servlet of your very own. HTTP servlet provides methods that are invoked based on which HTTP verb was used with your request. And so one of the things you'll learn about in the web lecture is that there are different verbs associated with a URL request. So you can say things like, okay, here's the URL, just get me that content. So that's like, downloading an image or something like that. It's like, oh yeah, give me that content. There's also a post. Now, if you did any HTML forms programming back in the day, when you wanted to submit data back to the web server, you used a post. It was like, hey, here's the URL, and send some information to that URL. That is, and HTTP supports all of that. There's also other verbs like put and delete. I think for the purposes of this assignment, you just use get and post. That's enough. Right. So, So now, okay, so this is a Java object, right? It's a Java class, right? The syntax should look familiar. You're just using this other API. So the same way that you've got your PhoneBill class that extends my abstract PhoneBill, now you have your PhoneBill servlet, which extends HTTP servlet. And this is the thing that implements the behavior of your web service. And it's a very simple thing. So what it does is it maintains a dictionary, which is a map of string to strings that has those words and their definitions. And so, when I do a get URL on this on the servlet, it does the following. doGet has two parameters. One is called HTTP Servlet Request. This is another class that is provided by the Servlet API. This is a thing representing the data that was sent to the server as part of the request. And it also has a servlet response, which is an object that represents what is returned from the service to the caller. And so the first thing that we do is that we say, okay, the kind of data that we're going to return is plain text. This is important because it tells the client, the person making the request, what kind of data is it? What do I do with it? Right? And so these are MIME types, right? So you've probably seen things like, oh, there's a JPEG type, and there's a well, you haven't seen things like XML and all that kind of stuff. But the whole idea is that when you the servlet, the HTTP in the HTTP response, you say, hey, here's the kind of data that I'm sending you, and here's the data, right? Because the data could be text, it could be binary, it could, well, I guess those are really two options. It could be text in a certain format, it could be binary in a certain format, right? It could be a JPEG, or it could be a GIF, or it could be a GIF. GIF? Is that still a thing? Anyway. East Coast, West Coast? I don't know. So anyway, so the first thing you do is say, hey, here's the kind of information, here's the kind of data I'm going to send you. And then you do your work, which in this case is the following. You say, hey, listen, if there was a parameter in the request that has the name word parameter, so word, then store it in that word variable. In this case, I don't, and we'll dive into a little bit more of this in a second. It's null, so that means that I write all the dictionary entries to the response. I'll just dive into that. So I get a print writer, which I hope is familiar to you from the Java I/O lecture. This is one of the nice things about the Servlet API, that the Servlet API takes advantage of or reuses a lot of classes from Java I/O. Right? They need a class that writes text to some destination. Well, Java already gives you one of those, so just reuse the one from Java I/O. They don't try to reinvent the wheel, or the print writer in this case. And then I write stuff to that print writer, and when I write stuff to that print writer, it actually ends up going back to the client via the HTTP servlet response. So I'll skip over the details now, but we flush the streams. This is another important thing. HTTP responses have status codes associated with them, right? We've all seen 404, right? Well, do you know what 404 means? File not found. What defines the fact that 404 means file not found? The HTTP standard, right? This isn't magic. It isn't arbitrary. Well, it's kind of arbitrary. It's called 404. Everything in the 400 range, has a certain meaning associated with it. It was deliberate. But this is like, this is sort of the underpinnings of the internet, is this HTTP protocol and how all of that works. And here again, lots more details in the lecture on the web. So what we got to do is, again, the response consists of, here's the kind of data that I'm sending you, here's the data that I'm sending you, and okay, yeah, here's the status of it. Because maybe something went wrong, in which you want to say, oh yeah, there was an error. Or maybe, and there are also different kind of statuses that you can convey. Some of them are related to things that go bad. So for instance, like you sent me a request that I didn't know how to handle. That's a particular error that's a particular status code. You asked for something that doesn't exist. That's 404. You don't have permission to perform this operation. There's ways to encode this. And what this allows you to do is, well, it's a protocol, right? It's a contract. And so what REST does is it leverages all of this contract that's there in the HTTP protocol to then provide essentially an API for doing CRUD operations. You know what CRUD means, right? Create, read, update, delete. You know, performing data operations on some piece of data. So the last thing you do is you tell the response, okay, yeah, this request was handled successfully, and go and do that what you will. Okay, and so you write that, and then you're all done, and then you go back, your method is done. And you interact with those objects, and then what the web container does, the thing that ultimately called this method, that takes the information in the objects and turns it into an HTTP response and sends it back to the client. In this case, the client is this command line. Oops, I guess I need to, sorry, I'm still in the debugger. I need to say continue on the debugger. There we go. And now it returned, and what it returned was dictionary on server contains 0 words, which was what was written by, which was written by this call right here. I should have dove into it. Here I am invoking the REST API and making the HTTP request to the server from the command line, but there are other ways of doing this. So, you might have heard of something called a web browser. Never mind. Okay, so all that command line is doing is asking for a URL, and you can ask for that same URL in different programs. So if I say 8080, and well, if I just hit 8080, this says, oh, hey, this is a Jetty server. I don't know how to handle that request. Did you really mean this one for this PhoneBill application? So yes. So I have this PhoneBill. The PhoneBill web application is what's created by the Maven Archetype, and we deployed it into our Jetty server. And one of the things it contains, let's just go here, is a file called index.html, which is an HTML, and my HTML is awful, that is served up when you hit this URL. It's kind of the default, content that's there. And what this thing does, I don't know if you're familiar with HTML forms, is that it allows you to interact with the calls URL. So if you go to the calls URL, that prints all of, well, when you implement it, it will be the phone calls in the PhoneBill, just like here. So let's go up to the URLs. Right, so this guy right here, that's the URL that you're implementing. And when you hit this URL, that's what gets routed to the servlet. I think that'll make more sense now. So anyway, so you can hit that URL with an HTML form. And so when I hit submit, we're back again in Java land. So I hit that URL, got routed to the servlet that's being debugged here. And we've got the same thing that we just did before. So we look at word. Word is null. And so then we're going to write all of the dictionary entries. We're going to go in here. We'll go into this thing. Basically what we do is we, I guess I don't have a, can I get the information about the print writer? No. You go through and you loop over all of the entries. If there were ones, we would write it there, but there's not. So we just fulfilled the request, and then we continue on in the debug session, and poof, now when you hit this URL in the browser, you get this information here. Let's try it again, do something different. Now we're going to, let's create a dictionary entry. A baloo is a bear. Is anybody old enough to get that reference? Yeah. Oh, man, really? Okay. Do they still give those same standardized tests to kids? Everybody? So for those of you who don't know, it was what, the California Achievement Tests, I think is what it was. Yeah. So it was a standardized test that I took as a little kid, and every year the test would be different, but the example for like how to fill in the Scantron form. Do they still use Scantron forms? Little bubbles that you fill in when you take tests. Okay, some people, it's all computers now, right? My kids have Chromebooks and stuff that they use. So anyway, and they give like these definition words, like a baloo is a bear, and like one was like a pip is the tooth that the bird, when it comes out of its egg, uses. Anyway, yeah, it was the 80s. Okay, okay. So now I'm creating some data here. And so then, what's another word with a definition? Java is a fun language to learn. Oh, no. Doe. A deer, female deer. Submit. Okay. So I made the definition. And now if I want to look up a blue, oh, I'm back in my get method again. So we'll take a look at what defining a word means in a little bit. So now, okay, let's see what happens. Let's look at the index.html. So when I clicked on the second form, which is this one right here, which is list a definition for word. Now, in HTML forms, you have those the text fields that you fill in, and this is represented as an input tag in HTML. And when I click submit here, what it does is it takes the inputs and it submits it on the URL. So actually, if we go and let's look at the request, and let's do the following. Well, let's go over that line, and let's look at the request, evaluate expression, and let's see here, request, what does it give us? Okay, cool. The URL, actually we can look at it right here, I guess, in like this toString. Yeah, that's not very interesting. What it calls is localhost 8080/PhoneBill/calls question mark word equals blue. That's the word that we are looking up. And so what that form does is it creates a URL that has the word equals blue on it. And oops, I'm going to close this right now. And now let's dive into this get parameter method to see what it does. Word parameter is a constant, which is just word. And what this does is this is a helper method that interrogates the request object and gets the value associated with the key word from the request. So it calls the get parameter name on the request object. Sorry, the get parameter method with the name, which in this case has the value word. And it returns the value blue. So that's the value that came out of that parameter. Now, up here, our word is blue. So now what we're going to do is we're going to write the definition. From here, and this is where now this is the application logic, kind of dumb application logic, right? It's no phone bill, but it's something that's to demonstrate how all of this works. And so I have my dictionary. Right now, my dictionary has, this dictionary has two things in it. It has doe, a deer, female, a deer, and blue is a bear. It looks it up. So it looks up the word blue in there. Sure enough, definition is a bear. And then I write it out to the HTTP response. And I flush it, and the response was handled just fine, so the status is okay. And we're done with all of this code. So we continue there. And now it's written out blue is a bear, but look at the URL, right? The URL is word equals blue. So now if I do the same thing here with, doe, it hits it again. I'm just going to continue on here so that you can see now it returns the definition of doe. So we've now seen three ways of we've all seen three ways of invoking the same method on the server, this do-get. We've seen it from the command line. We run this program that hits this URL. And we've seen two ways of doing it in the browser. You can just load the URL directly. I'm going to take it out of debugger mode so things are a little faster, not so much back and forth. It loads it directly. Let's just go back to blue. Oops. Blue is a bear. And then we also saw that we can access this through a form, and really all the form does is just calls that, it redirects that same URL. It hits that same URL. The lesson that I want you to get from this is that the code on the server side doesn't care what the client is. All it knows is it gets a request. The request can come from any kind of client it wants. It doesn't care. It's just talking HTTP. So you can invoke it in a number of different ways, and there's power in this, right? Because sometimes what you want is, you want a command line interface? Great, here's a command line interface. You talk to HTTP, the server doesn't care. Oh, you want to hit a web browser? It talks to HTTP, the server doesn't care. You want to do it in some like Android application. You hit the HTTP, use HTTP. You hit the REST API. The server doesn't care. So the whole contract here is that you've got some service and then you've got a REST interface to that service. I'm going to show you one more thing to round out the servlet discussion, and then we're going to take a break. Okay. So far, we've seen what this doGet method does. And if you look in your PhoneBill servlet, and this is a method that is inherited from something in HTTP servlet, so a standard method that you override. And again, this method is invoked by Jetty when it receives that request from whatever client. And what get does is it just queries the data. There's another method called doPost, which is what implements the functionality to populate the dictionary. And we'll walk through that now. So actually, well, here, I won't debug it quite yet. I'll show it to you, and then we'll debug it. So, Ray, a drop of golden sun. So you do that, and notice that the URL here is calls, and that'll be important in a moment. And now if we go and look at all of the all of the calls, it's got everything. Okay. So now let's set a breakpoint here and see what happens when this doPost method is called. Right now, golden sun. Me, a name, I call myself. Okay. A post is a different verb that you use with the URL. And in a post, you're telling the URL, hey, please do something with this information, which is usually, actually, it means make a change with this information. So in this case, what we're going to do is we're going to populate the map. Okay, so it's the same URL, the same servlet, but it's a different action on that servlet. This is going to take some information from the request and return some information in the response. The text type, the data type returned in the response is going to be plain text. So we're going to set the same thing we did. What we need to do now is get information from the request. This again comes in through the request object, and we have this helper get parameter method to extract information from that. So here the value. So word parameter is word. Word what we sent in was me, and sure enough, when you get the value of the word parameter, the word is me. Notice that if the word was null, we would throw an error, and I don't know if I can show that. I don't know if I can demonstrate that with these clients. I don't think I can. But there are two pieces of information in the request. One, right in the form, I put in me and then a name I call myself, which was the definition of that word, and that gets sent. If you look at the form, there are two inputs here. Sorry, there are three inputs. One is the word, one is the definition, and then you have submit. So this passes in two things to the URL in the post. Now when you get the definition, you see the definition is a name I call myself. If that was missing, it would also complain. And actually, let me just quick show you what missing required parameter does. What it does is it gives you an error message, and then it calls a method called sendError on the response, which says, wait a second, this is a bad, the request, what do I say? The request was bad, you sent me a, you were missing something, and the details about it are in that message, but the error code that's returned is this precondition failed, which is an HTTP 412. So like a 404, which is missing, this is a 412, which means that, oh yeah, some precondition failed. The whole idea is that REST API should leverage all of these standard error codes as part of their communication. They're akin to exceptions in Java, right? How you've been learning about how you have a method in Java. It provides a contract. The contract is represented in the arguments to the method, so its inputs, its output, the return type, and the return value, and then also the exceptions that it throws. Right? It's all part of the contract, all part of the interface for the method. Same thing here. When we want to convey an exceptional state, we do it via the status code.
So I see that it says throws an exception. Is that considered the exception?
No. Very good. Okay. So for the servlet API, well, actually, if you did have, let's say as part of the implementation of a servlet method, you did have a, okay, sorry, IO exception is thrown here because I'm pretty sure send error declares that it throws IO exception. So it's possible, I think a lot of the servlet APIs declare they throw IO exception. They're doing IO, right? They're writing to some stream that goes back to the client. They're doing IO, something could go wrong. When something goes wrong, an IO exception is thrown. So a lot of the API does, and so therefore a lot of your usage of the API needs to handle that IO exception, and here it's just easiest to throw it all the way up the stack. What will happen, I'm pretty sure, is that if your code does throw an IO exception that isn't caught by your code, instead you send it back to Jetty, Jetty will say, oh, look, IO exception, and will then convey that back to the client in probably at least a 500 error, and maybe it'll expose some information in production. It really shouldn't, but it sure helps in debugging. Good question. So we're at our do post. We got our word, we got our definition, and then our business logic here is just to put that in the dictionary, and then we put a little bit of stuff in the response. Here it was okay because they gave us all the required parameters. Moving on, it prints out this stuff that was returned to the print stream. That same method is invoked in the command line when we do, re, mi, fa. A long way to run. Hit the same method again. So let's walk through it. Word is fa. Definition is a long way to run. We put it in the dictionary. We got it. Again, different client, same stuff on the back end. Really nothing there. And now if we go and ask for everything here, we'll see there it is. And basically all this command line does, and we'll take a look at that in a little while, is it just hits this URL, phone calls. There it all is. So that's what your servlet does. Did it make any sense? Sort of get what it means? There's some magic here, and it's okay to believe in the magic. The magic is all the stuff that happens in the web container. Basically what we've done, and there's more details in the lecture, is that we've configured this web app. We've started up Jetty, and we've done what's called deployed a web application there, and that web application contains some configuration, some plumbing that tells Jetty, okay, when you get a request for this URL, route it to this servlet. And this is super cool because it's like this, here again, I keep using this word contract, but there's all these ways of sort of wiring all this stuff together so that Jetty, which is some open source tool written by some lonely guy in Finland or whatever, he doesn't need to know anything about your code. He or she, sorry, it could be a lonely girl in Finland, writes this code, provides this contract, and you can you can work with this as long as both sides respect that contract. Okay, time for a break. Let's take 13. We'll come back when the big hand is on the 12.